Problem number 167, which is 2 sum part 2, and where input array is sorted. So let me just explain what this question is asking to us. So basically what we have an array and we have to return the indices of those two elements which give sums equals to target, and we have to remember that the index is one base index rather than zero base indexing. Pretty simple. So there's one more thing. There's a follow-up. You must solve using only constants extra space. Well, you don't have to use any space. Your space complexity should be big O of 1. So let's solve this question. So for example, if we have this question here, 2, 7, 11, 15 and target is 9. So basically you have to return those indices of those two elements whose sum give up to 9. Okay. So basically first when you look at the question, it's pretty simple. If you just want to think using brute force way, you can use big O of n square complexity using two for loops. You can select an element and you can subtract the target. Okay, like if you choose 2, now your target will be 9 minus 2, which will be equals to 7. So you have to look if this 7 is present in the whole array or not. Okay, and if it exists, then you will return the index of the 2 and the index of 7. Pretty simple. Or if it doesn't happen, like 7 is not there, let us suppose, so you will move to the next element 7, then you will check after this key the target minus 7, for example 9 minus 7, or target, let us suppose target is 11, so 11 minus 7, which will be, I can take 21 minus 7, 14. So look if 14 is present in the array. Okay, that will be the brute force way, big O of n square. So it will give TLE. So rather than using this, we'll use much optimized way. The more optimized way how to think of that is, the best thing that I can give you for that is the input array is sorted. If the array is sorted, for example, if you selected this element, for example 2, the target changes to 9 minus 2, which will be equals to 7. Okay, then you have to search 7. Simply the thing you can do a linear search, which will give you time complexity of big O of n square, or rather you can do what is, if array sorted, to search any element, which algorithm do you use? Use binary search. Okay, and you can use binary search to search the 7. Binary search is just pretty simple, you must be knowing. I'll be explaining you, not much in detail, but yeah. So you are looking for 7, your low will be the ith pointer plus 1 and high will be here at the last. Every time it will be I plus 1 at the position of low, and the high will be at the last. So what will do, you find mid. Okay, mid will be 2, 3. Okay, it will be 1 plus 3 minus 1 by 2, which will give you 2, which will give you 2. Okay, your mid is 2. This is your mid. You will check if mid is greater than the target. Okay, so you can see the value at the mid is 11, which is greater than the target. It means if we have 7 in this array, we don't know yet, if we have 7 in this array, it will be in the left hand side. Why it will be in the left hand side? It's pretty simple, because array is sorted, and if you are finding 7 which is less than 11, it will be on the left hand side. And if the value, for example, if it is 70, let us suppose, we came at 11, we saw 70 is greater than 11, so it will definitely be at the right hand side if exists. Okay, let me show you the iteration. We found out ki 11 is greater than 7, so we move high pointer to mid, or you can say mid plus 1 also. I'll move mid minus 1 here, and we'll again find out mid, which will be 1 plus 1 minus 1 by 2 which will be 1, mid will be here, and we found out 7, the value at mid is same as the target that we want to find. So we will return the answer. So what will be the time complexity of the solution that we just thought? Okay, definitely we are not using any space, so it will be O of 1 for space complexity, and for time complexity it will be n. Like if we are choosing any element, like if we choose 2, if we choose 7, if we choose 11 and all, and for binary search it will be log n, n log n. This is a good solution, it will be accepted, it won't give TLE. The thing is, can you think of a better solution? The interviewer will ask this thing only, rather than just mugging on the solution, just try to optimize. Because this question is asked a lot of times in Google and other big tech giants. So if we look how to optimize, the answer lies in the last approaches that we used. We use pointers, okay, and in question itself it is given you can't use extra space, so you definitely think of pointers. Okay, let me rub this. I'm going to tell you big O of n solution. So okay, you think of pointer because first thing you used binary search. Okay, second thing, what in the question it was given no extra space. Okay, somewhat like binary search will form of the solution. So like we have this array, okay, we have pointer here, let us suppose low pointer and high pointer. And let me write this and explain. The target is 9. So what is the value at these two positions? The value is 15 plus 2, which is 17. Okay, or you can say sum is equals to 17, which is greater than the target. Okay, like you found out sum is 17, which is greater than 9. So where your answer can lie? The thing is, your answer will lie in the left hand side. Why? This is pretty simple, because if you choose a smaller element than 15, it will take you more closer towards 9. For example, if you move h from here to here, what will be the sum? Which will be 13. So 13 is more closer to 9. Or you can move here also, depends upon the iteration, number of iterations. You will move here, so it will be 7 plus 2, which will be 9. So what we found out, if sum is greater than the target, you'll move your high pointer to the low position or the previous position, or what you can say h minus minus. You can do h minus minus. Okay, so you moved h here. Okay, and if you move again h here, you'll get the answer. So let me take another case. Like your target is, let us suppose, what should be the target? 17. Let your target be 22, for example. And like the current sum is 15 plus 2, which is 17, and the sum is less than the target. Like 15 plus 2 is 17, which is less than the 22. So you want the sum to be more. How you can have sum to be more? Simply move the left pointer here, or increase the left pointer. Earlier it was here, it was giving you 15 plus 2, it was giving you 17, and if you move it to the next position, it will give you 7 plus 15, which will be 22. Okay, and you can see it is same, but basically if you move left to the right hand side or increase the value of L, it will give you much greater value. So if your sum is less than target, we'll move else if and if you can say, or else if, doesn't matter much, I'll recommend else if your sum double equals to target, what you will do, you will simply return the index l plus 1 comma r or h plus 1. Let me rub this, h plus 1. While you add 1 because it was one based indexing and you have to return according to that. So let me take you to the coding part and show you. We are going to code up the solution. Don't focus on this. Okay, so we'll code up the most optimized solution. So first we need pointers and left and right pointer, which will be pointing to the starting and ending, and n will be the size of the array. Okay, and we'll run the loop while left is less than or equals to h, and we'll find the sum, int sum equals to array l plus leftmost value plus rightmost value. Okay, if the sum is less than the target, okay, if it is less than the target, what will do, you do l plus plus. Else if sum is greater than the target, if your sum is greater than the target, simply what you'll do, you'll try to look for the lower value or the lesser value, so you'll do h minus minus. And if you found out the solution, else return l plus 1 comma h plus 1 plus 1, as it is one base indexing. At the last you will return an empty vector. So let me run this code quick. So there's some error, numbers l plus number h, numbers, it should be s here. Let me submit. You can see it is beating the 90% of the solution. And if I show you the earlier solution that I explained using n log n, so this was the solution, a for loop, and inside that for there's a while loop. So I recommend try to understand how to make the intuition rather than just gulping up the solution. Okay, so thank you for watching. You can subscribe to my YouTube channel. Bye bye. I don't believe in destiny.